So today we're going to start with properties of radicals, and there's two properties of radicals that you need to use. One is product, and one is quotient. One is multiplying, one is dividing. So when you look here at the product property, it says that if we have an nth root, we have some sort of root, and there's two numbers that multiply together underneath, you can split them apart to the separate same root. Just multiply those numbers. And we've done that before. When we have something like the square root of 50, you can multiply square root of 25 times the square root of 2, so we could simplify that. Remember, we've done that before. What's this simplified? 5 square root 2. Well, today we're doing that with more than just square roots. We'll do a cube root, so fourth root, so fifth root. We'll do it with more than just square roots today. Same concept. Also, it goes backwards, so if you have them multiplied outside, like the separate radicals, but they have the same root, you can put them underneath that same root. So if I have something like the square root of 3 multiplied by the square root of 3, I can say that's the square root of what? And how'd you get 9? 3 times 3? Yeah, 3 times 3 or 3 squared or 9. It just happens to reduce the square root, not square root. It happens to reduce the 3, right? The second part is the quotient property that works just like the product, only we're talking division instead. So if you have one root and you're dividing two numbers underneath it, you can break it apart to separate roots and then divide their answers. Or, if they're separated, you can make it one root and divide the things underneath. It's kind of what we did yesterday where we had everything to the fifth power and we pulled that fifth power out and did the stuff on the inside. Just like that. So here's where we might use some of those properties. Question A, we've got the cube root of 12 times the cube root of 18. See if they're the same root? So I'm going to take that root and do 12 times 18 underneath that same root. Can you multiply 12 times 18? Who did it already? Thank you, David. And then we ask ourselves, is that a perfect cube? We made lists before. If you need to make lists, you can always make lists like 2 to the third is 8. 3 to the third is 27. 4 to the third is 4. 5 to the third is 125. 6 to the third is 160. Oh, it is 6. Excellent. Next, we have a quotient. We're dividing. I'm going to use the quotient property since they're both fourth root. I'm going to put this division under one big fourth root. Why would I want to do that? 80 divided by 5 is something that I could do. Make it simpler. What's 80 divided by 5? 16. Thank you. And is that a perfect fourth power? What to the fourth gives me 16? 2 times 2 times 2 times 2 to the fourth. So the answer is 2. Now I'm going to continue. It says student practice. I'm going to continue talking. Sorry. All right, we've got the third root of 4 and the third root of 128. Multiply this together all under the third root. Brooke's going to do it for us. Yeah, I'll do that. 512. And I'm sure you all have that memorized, right? What's the third root of that?
Oh.
Well, if you don't, there's a button on your calculator. What's the third root? Did you do it, Aiden?
What? Oh. No.
You do it, Reed?
Oh, where's the button at?
Nah. Find it because I'm not going to do it for you on a quiz. So 512 is the same thing as 8 to the third. And so if we're taking the cube root of 8 to the third, we get 8. The next one is a quotient. Should I put the fifth root around the whole thing? Like, are those going to maybe reduce? Well, I know they're both even. So might as well try. You got a calculator? Oops, I wrote that wrong. 192 divided by 6. Does that work evenly? How many times? Okay. So then, is that an answer we can find? The fifth root of 32, you shouldn't need a calculator for this. It's 2 to the fifth, right? So then, if I'm doing the fifth root of 2 to the fifth, my answer is 2. 512, I understand you need a calculator, but 2 to the fifth, we've been doing a bunch. So those, you got to start memorizing. Because you use them. Oh. All right, the next page has a bunch of stuff at the top that describes what I'm going to talk about, but I'm not going to read it word for word. I'm just going to do examples. So cube root of 135. There's no operations on that one. So cube root of 135, we got a perfect cube. Tap it in. Reed's doing it. He's on it. You don't know where that button is. That is not a perfect cube. But we're asked to simplify this. We're not asked to round it to the nearest whatever. So you have to do what we were doing for square roots, but we're going to do with cube roots. So you make a factor tree. I'm going to make a factor tree, and both of these are going to be cube roots. So what two numbers multiply together to give me 135? But one of them has to be a perfect cube. So I just made that list. I don't know how fast you wrote it down, if you wrote it down at all, that list back here. Where I was making like cubes. Do any of those perfect cubes go into that number?
27.
27, how many times? Okay. So I'll write this as cube root of 27 multiplied by the cube root of 5. So you just check numbers on that list. When that 27 goes in evenly, break it apart. Then what's the cube root of 27? 3. And the cube root of 5, we don't have one, so we just bring it down. And then simplify it. Next example. Would it make sense for me to rewrite this as the fifth root of 7/8? Notice I can't reduce 7/8. So it must be done, right? You would hope so, except for there's this rule that you should have learned in a previous course that, I don't know, a lot of people in my other class have forgotten it. You're never allowed to leave a radical in the denominator. World up. Just to be the definition of it being in simplest form is that we shouldn't have a radical in the denominator. So if the directions say write it in simplest form, you can't leave a radical down there. If I rewrite this as fifth root of 7/8, that's still a radical in the denominator because it breaks apart and it's still in the denominator. So what we have to do is we have to get the denominator to be no radical at all. I'm going to show you how to do that. This is called rationalizing the denominator. That's what it's called. It probably says it up there. What I want to do is I want to factor the 8. I'm going to factor that 8 the way that we were factoring last week. We take 8 and you write it as a base to an exponent. What can I make 8 into? That is equivalent to 8. As a base to an exponent. Oh, we better make a vector tree then. What's 8? 2 and 4. There's a prime number. What's 4? 2 and 2. So 2 to the third. Thank you. So on the bottom, I have the 5th root of 2 to the third. So there's my first step. I factored that 8. I just made it 2 to the third. Now, in order to take a 5th root, I have to have 2 to the 1. What can I take the 5th root of? 2 to the 5. Do I have 2 to the 5 right now? No. I have 2 to the 3. How many more 2's do I need? So what I'm going to do is I'm going to multiply by the 5th root of 2 to the 2. So total, I will have 2 to the 5th down there. But if you're going to multiply the bottom, to keep the value the same without changing the value, you also have to multiply the top by the same number. So now I'm multiplying a fraction times a fraction. This fraction is equivalent to 1. So I'm not changing the value at all. And remember, we multiply fractions by going straight across. Don't fall in that hole. So straight across. On top, since they're both 5th root, I can write the 5th root of 7 multiplied by 2 squared. On the bottom, since they're both 5th root, I can write the 5th root of 2 to the 5. Because I add my exponents for the 2's. I'm going to simplify that. So on top, I'm multiplying the 5th root of 7 times 4, 28. On the bottom, I'm doing the 5th root of 2 to the 5th. If I change that into a fraction exponent, that would be 2 to the power over root. And 5 over 5 is what? So it would be 2 to the first. What goes down there? 2. See how we don't have a radical in the denominator anymore. We just have the number 2. So yay, it's a now in simplest form. This is not something you will magically come up with without actually practicing. You can watch me do it all day long, but if you don't actually do it yourself, you will not remember this. Here's student practice. Again, I'm going to do it with you, though. Okay, 4th root, 27 times 4th root 3. Ideas? Put them all under 1, so we're going to do 4th root, 27 times 3. So I got 4th root of 81, and is 81 something to the 4th? $81 is the same thing as 3 to the 4th. So my answer is 3. Next example. Does it make sense that I would make the cube root over the whole thing? What? Because I can reduce 250 over 2, yeah. So I'll go ahead and make 3rd root 250 over 2, reduce that. 3rd root 125. Is that a perfect answer? What is 125? 5 to the 3rd? So we get 5. So close. All right, 104. That is not a perfect cube. So you're going to have to draw a factor tree with cubes. And if you go look at that list, or make your own, go look at the list. We need to divide 104 by one of those numbers that goes evenly. What do you think? Carly, did you find it? Stuart, did you find it? You guys aren't pressing buttons. Take 104 divided by any of those numbers on that cube list. They all wrote down when I was writing them down, right? Did you find it? Huh? Did you write it down? Why not? I can't read your mind. Charlotte, did you find it? Emma, did you find it? Well, what's the very first third power that you would divide it by? Remember I made a list, I went something to the third, I went something to the third, I made that list. What's the very first thing on that list? Did you try 2 to the third? This is the very first thing on the list. When you divide that, you get 13. I know I can't break down 13 any further, so that's it. So the cube root of 8 is 2, and then the cube root of 13 is left. You have to be able to do this on your own. You have to use that list and start dividing them. But I didn't write down the list.
I get it.
I didn't write it down. Yeah.
Can we use a list on like,
You can make your own list at any time you want.
I mean, just to save time?
No, I'm not gonna make one. I have them memorized. I don't need to make one.
Wait, can we like, if we make a list, can we use it on the test?
You would have to make one during the test. You cannot take something you already have and use it on the test. Okay, number 8. 3/4 does not reduce. So I'm going to break this apart. And can I take the 5th root of 4? I know I can't take the 5th root of 3. Can I take the 5th root of 4? No. So I have a radical in my denominator. Can I have a rat in the den? I have to exterminate. So I'm going to factor. I'm going to factor this 4. Factor. What is 4 factored? So I get the 5th root of 2 squared. Then you say, how many more 2's do I need down there so I complete the 5th power? How many more? 3 more. So I'll go 2 to the 3. But I have to do it on the top. We multiply together. We get the 5th root of 3 times 2 to the 3 over the 5th root of 2 to the 5th. So on top I get the 5th root of 24. On the bottom, 2 to the 5th root is just 2. Okay, we got one last time to learn. So now, when you look at this example, your radical in the denominator is not alone. Your rat down there brought a friend. So you have to exterminate the radical, but like it's got company, so you gotta do some more. When there is a radical with a friend down there, you can't just multiply by the radical and cancel that out with what we were doing. You can't do that. You're gonna have to multiply by the conjugate. The good thing is, we've already learned about conjugates, and we've already multiplied with them this year. So this should somewhat go fast. But you're gonna have to multiply by the conjugate. Remember, the conjugate means if I have a term of two terms, the sign in between just switches to the other sign, and then they're conjugates. Just the sign in between switches, that makes them conjugates. So we have our original question of 1 over 5 plus radical 3. I'm going to have to multiply by the conjugate on the top and the bottom. I'm going to multiply by the conjugate of the denominator. So looking at the denominator, what would its conjugate be? Excellent. Now, I have to do that on the top and the bottom because it has to be a value of 1. Here's something people forget is when you're multiplying two terms, technically they are in parentheses, but they didn't give them to you. So you have to know there's parentheses there. And on top, we're going to distribute. And it's easy because it's just 1. On the bottom, how do you multiply two terms times two terms? We've done that a bunch this year. Two terms times two terms, how do I multiply you? Foil. The opposite of factor, though. Thank you for pulling out any word that had that. Let me repeat that. Any good word that had that. The FOIL, remember you first outer, inner, last. First outer, inner, last. Okay. So we're going to do 5 times 5. That's our first 25. Outside is 5 times minus radical 3, so minus 5 radical 3. Inside is plus 5 radical 3. And then last is minus radical 3 times radical 3 is 3. We've done this before. When you multiply by conjugates, if you've done it correctly, what always happens in the middle two terms? Always cancel. And then this term will always be minus if you've done it correctly. Always. Was it number 11?
Yeah, sorry.
That's all right. I was like, I don't know where that one is.
For now, it's 4.
Oh, it's 4?
This is part 4.
Okay, so then we have 5 minus radical 3, and then on the bottom I have 25. Take away 3, 22. Now there's 3 rules to know after you've done all this to know that it's officially like in simplest form. And we've talked about these rules before. I'm going to just jot them down real fast. 1, denominator is positive. Okay, so denominator has to be positive. Second thing is any square roots that are still there, radicals, have to be simplified. So square root of 3 is as far as it'll go. And then the third thing is factor out a number from the top and cancel it with the bottom. Remember doing that? We're going to factor something out. So we just got to check these 3 things. And we're going to do the next example. This one's fine. Nothing could be done more on this one. But the next one will have something we can do. If you can't read my writing because I wrote really fast, just ask. Maybe I just rewrite that first word because that's pretty bad. All right, so our next example, We have a radical in the denominator and a friend. So we have to cancel it out. We're going to have to multiply by the conjugate. What's the conjugate? 1 minus radical 6. You have to do that on the top and the bottom. These are all in parentheses, even though they are not written there for you. So on top, we distribute. I get radical 2 times 1 is radical 2. Minus, when I get radical 2 times radical 6, they're both square roots. So multiply them together, square root 12. On the bottom, how do I multiply 2 terms times 2 terms? FOIL. FOIL. So we're going to do first, outer, inner, last is going to give me minus, and then radical 6 times radical 6 is 6. So I've done it right. The middle 2 terms cancel out, the last term's minus. Square root of 2 minus square root of 12 over negative 5. Is this in simplest form? Why not? The denominator is not positive. So we have to change that. You are allowed to multiply by a number that changes negative 5 into positive 5. Do it on top and bottom. But remember there's parentheses here. So I have to distribute that negative 1 to the top. So now I have negative radical 2 minus, plus radical 12 over positive 5. Now is it in simplest form? No. Because the square root of 12 simplifies. The square root of 12 becomes what square root? With what? 4 and 3, and then what's 4 become? 2 radical 3. Remember doing this before? I know we've done it. So now I have negative radical 2 plus 2 radical 3 all over 5. And then there will be nothing I can factor out to cancel with that, so that would be my final answer. Okay, I've talked for a long time. The assignment is a big idea online, but if for some reason